camp and made a scale drawing. The sand volleyball court is 3 centimeters wide in the drawing. The actual volleyball court is 9 meters wide. What scale did she use? So we're going to find out. She used 3 centimeters and it was 9 meters actual. So this was her scale drawing and this was her actual. So what we're going to do is we're going to actually, it's like finding the unit rate. So we want to find out how many would be 1 centimeter. So if it's 3 centimeters, we want to find 3 centimeters equals how many meters. So whatever you have to do to get your first measurement to be a 1, so basically you're doing 3/9 and you want this to equal 1, what would you divide this by? So you would divide this by 3, right? Now you divide this by 3.
Mm-hmm.
So 1 centimeter would equal 3 meters. And so if we got our ruler out, we would do a scale drawing. 1 centimeter equals 3 meters. So if the volleyball court was, just say it was 9 meters by 9 meters by 9 meters.
Mm-hmm.
I should know this. I used to be a volleyball player, but I don't know the dimensions for a volleyball court. I'm sorry. That was a long time
That's
ago.
Fine. I wouldn't have expected you to.
I was in 8th grade. Okay, so each of these would stand for 9 meters. And this would be our scale drawing.
Okay.
Make sense?
Yeah, and that's all you have to do is find the meters and then
Yeah,
scale drawing.
so I will send this to you as well. It's the same website, it's just a different section. So you can just do a few of each section. And so all you would do is do 1 centimeter equals how many meters, it equals 3, and then you do submit, and then it would say, oh, you have to become a member? Come on. Let's see what we have to do to become a member.
It's not good.
Might be.
I'm sure there's like a free one.
Yeah. Let's see. Okay. So that is scale drawings. Let's see if they will let me go into exponent. So a quick review of exponents. You remember those, right?
Yeah. It's good we're doing reviews because a lot of these things I forget. And then once we do it, I'm like, oh.
Yeah, exactly. So I will just use your textbook because I did some of this with Marissa and Marcella.
Okay.
So
Are they doing summer geometry or what are they doing?
They are, yeah.
Okay. Nice. Yeah, I'm kind of a failure of a student, so I didn't really want to do that, so.
I don't think you're a failure of a student. You might be like, I want the summer off, which, I get that.
Yeah, that just wasn't the math course or whatever you call it, track I wanted to take.
Yeah, and there's something to be said about taking it slow and easy. So Ty did not. He kept getting pushed through. He didn't want to, but they kept pushing him through. And at the end, he was doing outrageous stuff, and he could have went into Calc 2 his freshman year of college. And so right now he's catching up because he took a gap time, and he's now taking an algebra. It's like an extensive matrix algebra, and I don't even know what he's learning actually. And it's so advanced. It's 4 or 5 hours a day, 5 days a week. And college is usually 3 hours a week. But because he's taking it in the summer, it's 20 hours a week, and he gets like 20 million problems to do. So,
Wow. That's
yeah,
crazy.
exactly. Okay, so I am going to find it in your book. 406. Okay, so we are going to do all of the. This is not what I'm looking for. Everything exponents will start from the beginning. So an exponent is a base with an exponent like this, right? You remember that. So if your, sorry, this is blurry. If your base is 5 and your exponent is 3, this means 5 times 5 times 5.
Yeah.
And for undoing this, if you see something like that, then they're factoring it out. You would then turn it into an exponent and a base. So it would be 5 to the 4th power.
Okay.
And then the product of powers. So if you had 2 to the 2nd power or 2 squared times 2 to the 4th power, you could do 2 times 2 times 2 times 2 times 2 times 2, 6, yeah. Which is one way to do it, or you can just add these two exponents together instead of writing it out. So you would add the exponents together, and it would become 2 to the 6th power. Now you take your calculator, and from now on, from all of history and life, you can use your calculator. Remember before when you couldn't, now you can. So then you would just do 2 to the 6th power equals 64. So that's all it is. So what they call it is product of powers. And what that means is when you multiply two, that's what they're doing here, they're multiplying. So when you multiply two powers that have the same base, that's the rule. So when you multiply two powers with same base, you add the exponents together. So they write it out like this. A to the m power and a to the p power equals a m plus p.
Okay.
And then in number terms, a to the 4th power times a to the 6th power equals a 4 plus 6, or a to the 10th power. Yep.
All right.
So because you're in high school now, it goes quickly into the next concept. So the next concept is something that looks like this. So we have the same base. So we know that this is n and n, and this is cubed, and this is to the 7th power, but we have to factor them out. So we need to combine like terms. So we're going to do 6 times 2, and then we're going to do n to the 3rd power times n to the 7th power. So these become two separate terms that we're multiplying. And then we're going to simplify 6 times 2 is 12, and then we're going to simplify this, n 3 plus 7, and now we go to the next line. This is 12, and then this is n to the 10th power. And because this is not an actual number, this is the as far as you can take it. If this was a 3 or a 2 or a 7, then you would be able to simplify it even more and come up with a number, but this is not. So this is as simplified as it could go.
Okay.
All right, the next thing is 3pt cubed times p cubed times t to the 4th power. So again, we're going to take all of the numbers and we're going to take those out. This is nothing, so you can either just do 3 or 3 times 1. And now we're going to do p to the 1st power and p to the 3rd power. And then we're going to simplify our t's. T cubed times t to the 4th power. Now we simplify even more. 3 p to the 4th power t to the 7th power. And because they are letters, that is as simplified as you could make it.
Okay.
So for homework, I'm going to have you do this problem right here. 3y to the 4th power times 7y to the 5th power. And then I'm going to have you do 4rx squared 6 r to the 5th power x to the 5th power. Okay, now we have power of a power. So they get crazy with their names. And what this means is you have an exponent, a base, and then that's put up to an exponent as well. So what this means is 3 to the 2nd power times 3 to the 2nd power times 3 to the 2nd power. Does that make sense to you? That you're basically taking all of this and you're timesing it 4 times. And you can absolutely do that. That is one way to do it. And then we know that when we're multiplying exponents like this, that what we're really going to do is do 3, 2 plus 2 plus 2 plus 2. So that's 3 to the 8th power.
So you could basically just, like, for me looking at this, can you just do 4 times 2?
Yep.
And then that would get.
Exactly. We don't want to have to do this, but that's what this means. So the shortcut is when you have, this is just the way they write it. I will always write it the way they write it, and then I'll show you it in numerical form because this is crazy looking. So when you have b to the 3rd power and then all of that to the 5th power, basically what you're going to do is do b 3 times 5, and that's b to the 15th power. So that is the shortcut. So let's do it in numerical form. So 3 to the 3rd power times to the exponent of 5. We know that this means 3, 3, 3, 3, 3, just so you're clear about what that means. And then we would do 3, 6, 9, 12, 3 to the 15th power. And then our hack or our shortcut is 3 times 5, 3 to the 15th power. And then we would just plug into our calculator 3 to the 15th power, which is 14348,907. 14,348,907. Boom. So they get.
Solve that without a calculator.
Yeah, no, we're not doing that. Okay. So because you're in high school, we go to the next concept. It's literally on the next page. The next concept is bracket 2 to the 3rd power in parentheses with an exponent and bracket to the 4th power. So what this means is 2 to the 3rd power times 2, right? We know when it looks like this, that we just multiply that together. And then all of that 4 times. So what that looks like is 2 to the 6th power 4 times. And then we simplify, we multiply these together. So one step at a time. We first multiply these together like this, and then we keep this on the outside. This turns into a 6. This turns into a 4 on the outside. And then we multiply this together. We don't take shortcuts to go 3 times 2 times 4. We just do it like this, one step at a time.
Wait, so why are there brackets around them and not just another set of parentheses?
Because they use brackets when you have parentheses, so it's bracket then parentheses. That's how they show it.
Okay.
Yeah. So parentheses inside parentheses get confusing. So for homework, you can do 2 to the 3rd power to the 2nd power to the 4th power. And then the next one is 2 to the 2nd power to the 2nd power all to the 4th power. Fun, right? Any questions? I know you just have to practice it until you get it. So you can, in your book, do you have your physical book or just an online book?
So no, but like I never saw this book like for algebra. Well, I guess I maybe saw it online, but like I never had it or like looked in the book or anything. It's crazy.
All right. Well, let me just show it to you then.
Okay.
So this was the first page, which was really nothing. That was just saying what a base was and how to unfactor it. The second page is how instead of having to write it all out like this, you basically just have these go together and add them because they are the same base. We can do that. And then we went to the next section, which was right here. And this is when we have a product of powers. So we're multiplying. We have the same base. We don't need the same number. We just need the same base. And then instead of having to write all of it out, we do factor out the number. So we took our 6 and we took our 2 and we put it in one set of parentheses. Then we take our n's and we do n to the 3rd power times n to the 7th power. And the reason why we do that is because we want to get all the n's together. If there was another expression like a q, we would take that and we would do the q's. So then we simplify and then we come up with 6 times 2 and then n, we add these together, 3 plus 7, So it becomes 12n to the 10th power. You want to make a key for this. You want this written down because even if it's just a small, because you're going to have it and they're not going to really go over this that much. So you have to know it, and you're probably not going to always commit it to memory, but you do want a piece of paper that has exponents on one sheet, all the things you do with exponents and all the definitions and everything. And then you want to make a toolkit so that you have a little thin binder or notebook or paper or anything that kind of is a reference to you, that gives you all of these things, so you don't have to keep them in your mind and you always have them.
Okay.
So that's the next concept. Then we have power of a power. So when we're multiplying like this, when we have a base and an exponent and we're putting that to the power, so we have a power of a power, you basically multiply these two numbers together and it becomes b3 times 5 or b15 to the 15th power. Then the next one is also an example of a power, and that is when you have the brackets and you have a base and an exponent by an exponent and then all of that by an exponent. You basically multiply these together, then you multiply that times this. So the steps are, you take these two numbers, you multiply those together, which becomes 6, and then you put it to the 4th power, and then you're now able to multiply these. So this becomes 6 times 4 or 2 to the 24th power.
Okay.
So that is what we did so far. They will start doing negative numbers, but we're not doing that yet. That's enough for today. That is a lot. And I will mark in the book. So if you do have a copy of the book, that would be great. You can have it printed out. So because you don't know your book, let me explain to you. If you can find a copy of the book, this book is amazing. I love it. And here is one of the reasons. First, it's very clear. The instructions are easy. This is lesson 7.1. So what you do is, this is what it becomes, Carter. Look at this.
That's crazy.
Yeah. At the end of your chapter, they have, so on, mine's different because I have the textbook, but so the study guide in the review section, it's page 452 on mine, but I know the online has different pages. It has all of everything that you need to do.
Okay.
And then it gives you an example of each concept. So it's phenomenal. This is everything that's covered in 7.1.
Okay.
And it's amazing the way they do it. So, yeah.
Yeah, I might try and look for like the book online. Like, I don't know if they have like a virtual like read through of it, but I might try and do that first, and then if not, I'll see if I can get it.
Yeah, I bought it online. I don't remember where I got it, but I just put in, it's Algebra 1. Oh, here's where I got it. I got it. Well, this is it. Algebra 1, Student Edition, CCSS, Glencoe McGraw-Hill, and here's the ISBN number. I might, just search it online. I paid $6 for it. It's totally worth it.
Okay.
Yeah, I would definitely get it. And yeah. All right, I should see your sister now.